Hi, I'm the Physics Boss Man, and today we're demonstrating how to work this physics problem. It's also going to be a nice example of the idea problem solving format. Olivia walks 1,250 meters at 15 degrees west of north, then 800 meters at 30 degrees east of north. Compute her total displacement from her starting point. With God's help, you can do physics boss as you are created.
You are created in God's image.
To be fruitful and multiply.
Fill the earth and subdue.
Do it. Okay, the first step I in the idea problem solving format is to interpret. And the best way to interpret most physics problems is with a simple diagram and also identifying the general principle of physics that's going to be used to solve the problem. So pictures often begin with a coordinate axis. So there's our XY coordinate system. Y corresponds to north on the compass. X corresponds to east on the compass. So Olivia walks 1,250 meters at 15 degrees west of north. Okay, and then 800 meters at 30 degrees east of north. And it says to compute her total displacement from her starting point. Okay, so we've got a pretty good picture. And to compute her total displacement, the general principle of physics that we need is vector addition. And we're also using the definition of displacement.
God has crowned you
with
glory and honor.
Honor to rule over his creation.
Creation.
Okay, so the second step of the idea problem solving format is develop. The D in idea stands for develop. And what develop means is it doesn't mean start thinking about which formula we need. It means make a plan. Identify a sequence of steps, what you need to do to solve this physics problem. And this is before you start thinking about equations and formulas. So one thing we need to do, and I like to write down a bullet point plan, is we need to convert angles to the angles relative to the x-axis. And that's because the next step is to compute the x and y components of each vector. Because to add vectors in physics, I know there's another way to do it. There's a parallelogram method. It's called different things. But in your physics courses, the most useful way to add vectors is to compute the components of the vectors and then to add them together. And likewise, in many places in your introductory physics courses, simply get in the habit of thinking about how do I compute the coordinate or the components of these vectors before going forward. A lot of student mistakes happen because you're trying to skip that step or find an easier path to a solution without computing the components of each vector. And then so, you can also identify the two vectors. We'll call A the first vector and B the second vector. So then, your total displacement vector C is equal to A plus B. So compute your components, make your identifications, and then, CX, the X component of your displacement is just the X component, the two X components added together, and the Y component of the displacement is just the Y components added together. And sometimes in our process of developing, we do start to head towards some formulas toward the end of that.
Science is a gift from God
to help us master nature.
But sin added thorns and thistles,
requiring the sweat of your brow to succeed. Okay, the first two steps in the idea problem solving format are interpret and develop. The third is evaluate. And that's in more of the physics context. You can also think about the E as execute, because we made a careful step-by-step plan and now we're executing that plan. So to convert the angles relative to the x-axis, let's start off with the vector A. It's 15 degrees west of north. So to make that relative to the positive x-axis, we have to add this 90-degree angle here to it. So 90 plus 15 is 105. So theta A is 105 degrees relative to the positive x-axis. And then theta B is actually 90 degrees minus 30 degrees because it's east of north. So theta B is equal to 60 degrees. Okay, so now we need to compute the x and y components of each vector. So the x component of A, if you remember, once you have the angles relative to the x-axis, the x component is always the magnitude of A times the cosine of the angle A makes with the positive x-axis. So that's going to be 1250 meters times the cosine of 105 degrees. And the y component is the magnitude of the vector A times the sine of that angle. And so, you know, a little calculator work is necessary there. We'll show that in a minute, but I'm sure everybody knows how to use their calculator by this point. So the x component of B is the magnitude of B times the cosine of the angle that the vector B makes with the positive x-axis. So that's 800 meters times the cosine of 60 degrees. And then, oops, somehow I wrote y, I meant x right there. No trouble. The y component of vector B is the magnitude of B times the sine of theta B. So it's 800 meters times the sine of 60 degrees.
Learning physics
Often requires prayer
as we submit
to Jesus Christ
as risen
King of Kings and Lord of Lords. Okay, so let's go ahead and carry forward some of our calculations. And one important thing at this point is to make sure your calculator is in degree mode. If your calculator happens to be in radian mode, you're going to get answers that don't make any sense. Alright, so the cosine of 105 degrees is negative 0.258, so we just multiply that by 1250. So the x component of A is 323.5 meters. The y component of A, first we compute the sine of 105 degrees, and that's like 0.965 and change times 1250. So that's 1207.4 meters. And now the cosine of 60 degrees, 0.5 times 800 is 400 meters. And then the sine of 60 degrees is 0.866 times 800 meters is, well, somehow I did that wrong. Sine of 60 degrees is 0.866, and then times 800 is 692.8 meters. So adding together the x components to get the x component of the total displacement vector. Now keep in mind, I think this one maybe should be negative. Let's double check this, because if you look at the picture, it's to the left of the y-axis, so that one should be negative. So let's double check that. So 105 degrees cosine, yes, it's negative 0.258 and change, so times 1250 is negative 323.5, and then add it to the 400. So that would be 76 point, round it to 5 meters, and then the y component is, add the two y components together, so 1207.4 plus 692.8, so that's 1900.2 meters. And my habit is to carry around some extra significant digits and only do the final rounding according to the significant digits in the problem, to do that as the last step. So you would probably want to, since the problem has 3 significant digits here, you might round them at this point and see how you express your final answer. If it just asks for the displacement, this is the displacement vector. And there are different vector formats. Sometimes you put them in brackets and you put a comma in between. And so this would be 76.5 meters and 1900 meters. Or it's also possible that in questions like this, rather than putting your final answer in component form, as we've done, they might want your final answer to be back in magnitude angle form, in which case the magnitude would simply be, you square the x component, you square the y component, you add them together, you take the square root, and then you compute the angle with the inverse tangent function. But since this one didn't explicitly ask it to be in magnitude angle form, I recommend, if they don't ask for magnitude angle form, just leave it in component form, and here's why. There's always chance of a careless error if you do more work than is really required. Okay, so interpret, develop, evaluate.
We reign by surrender.
We reign by surrendering to Jesus and praying for our daily bread, which includes success
In our schoolwork.
God will answer and lighten our yoke and the impact of the thorns and thistles in our labor. And then the last step of the idea problem solving format is to assess. And to assess the answer to a physics problem, we ask a few questions. Does the magnitude make sense? Does the sign make sense? Does the general gist, in this case the direction of the answer, tend to make sense? So let's go ahead and be a little more explicit about our process here in our assessment. Alright, so we added 2 vectors together, and the 2 vectors, this one had a negative x component, this one had a positive x component. So we added together the x components and got an x component that's a lot smaller. That's what happens when you're effectively subtracting, because the vectors were in different directions. And the y component kind of is bigger than either one of the constituents, and that's what happens when you're adding together things that tend to be in the same direction. So let's go ahead and talk about the magnitude. And I say that passes our assessment. And the direction, this vector is going to be up and to the right because both components end up positive, and the sign also passes our simple assessment. So that's it, the idea problem solving format: interpret, develop, evaluate, assess, and that's a good example both for vector addition in physics. Compute components, add the components together, and take it that way.
Written in the Word, in the good, good Word, is a message from our God. Gonna tell you all about how to get to the kingdom, the good life. Written in the Word, in the good, good Word, is a message from our God. Gonna tell you all about how to get to the kingdom, the good life. Oh, I love Jesus. La 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 la.